Good morning. So we are in Unit 4, Transition in a Transition Element. Last class we completed in detail about transition elements. We studied the important compounds of D block elements and we see the general properties and trends in the D block elements. Today we are going to start the F block elements, which are the inner transition elements. So in the inner transition elements there are two series of elements. One is lanthanoid, otherwise called as lanthanides previously, and actinoids, previously called as actinides. Lanthanoid series consists of 14 elements from cerium to lutetium. So it consists of 14 elements. Lanthanide series, how many elements are present? It contains 14 elements from cerium to lutetium following lanthanum. So lanthanum oda சேர்த்து it is having a lanthanum cerium னு சொல்லிட்டு it is having 14 elements. These elements, that is after lanthanum. So lanthanum, cerium continue ஆகும். These 14 elements are characterized by the preferential filling of 4f orbital. Similarly, actinoids consist of 14 elements from thorium to lawrencium following actinium. Same way actinoids la actinium da first இருக்கும், and then thorium, the continuously 14 elements will be there. So why these elements are placed in 4f F block? So lanthanum, the electrons are entering to 4f orbital, so it is finishing in 4f orbital. For actinides, they are in FIF orbital, so it is occupying the F block. What is the position of lanthanoids in the periodic table? So the actual position pathina, it is in the group 3, group number 3 and period number 6. Actually it is there. If you can see here, lanthanum 57 and actinium 89 it is given, but after later on only they discovered all the 14 elements. The space was not enough inside the periodic table, so they have to place it below. Okay, since they were in F block also. However, in the sixth period after lanthanum, the electrons are preferentially filled in inner F4F subshell, and these 14 elements following lanthanum show similar chemical properties. So sixth period after lanthanum, the electrons are எங்க fill ஆகுது, 4f subshell fill ஆகிறதுனால 14 elements எல்லாமே lanthanumல இருக்கு. So all they show similar chemical properties. All the 14 elements will be showing similar chemical properties, and therefore these elements are grouped together and placed at the bottom of the periodic table. So இது எல்லாமே ஒண்ணா group பண்ணி அங்க ஆல்ரெடி அந்த குரூப்ல இடம் இல்லை, டி பிளாக்ல இடம் இல்லை, அது மட்டும் இல்லாமல் they are in 4f occupy பண்றதுனால there was no proper position, so they have to place it below the periodic table, that is bottom of the periodic table. Lanthanides have general electronic configuration xenon 4f1 to 14, 5d 0 to 1 and 6s2. The common oxidation state of lanthanoid is +3. All these elements have similar physical and chemical properties. Similarly, the 14 elements following actinium resemble their physical and chemical properties. So எல்லா எலிமெண்ட்ஸ்க்குமே similar physical and chemical properties இருக்கு. ஸோ இதை வந்து நம்ம ஆஃப்டர் லாந்தனம்க்கு பிளேஸ் பண்ணோன்னா they have to be in the 4D series, which is not appropriate. So that is why they have to place it below or bottom of the periodic table. So what are the configuration, electronic configuration of lanthanoids? We know that electrons are filled in different orbitals in the order of their increasing energy in accordance with Aufbau principle. As per this rule, after filling 5s, 5p and 6s and 4f level begin to fill from lanthanum, and hence the expected electronic configuration of lanthanum is xenon 4f1, 5d0 and 6s2, but the actual electronic configuration of lanthanum is xenon 4f0, 5d1 and 6s2. So actually it should be this, but they are following the electronic configuration is 4f1, 5d0 and 6s2, and it belongs to D block. So filling of 4f orbital starts from cerium la irundhu start ஆகிறதுனால, so their proper electronic configuration என்னன்னா 4f1, 5d1 and 6s2. So as we move from cerium to other elements, the addition of other electrons are progressively filled in 4f orbital. So what they are saying when it comes to electronic configuration, they are writing for lanthanum. Lanthanumக்கு ரெண்டு possibilities கொடுக்குறாங்க, xenon 4f1, 5d0, 6s2, but the actual will be 4f0, 5d1 and 6s2 they are giving. Okay, but since the electrons are entering the f orbital, so they have to the electrons வந்து 4f orbital ceriumல இருந்து 4f orbital entry கொடுக்கறதுனால they should have the electronic configuration xenon 4f1 5d1 and 6s2. So if you see lanthanum atomic number 57, cerium is 58, praseodymium is 59, neodymium is 60, promethium is 61, samarium is 62, europium is 63, gadolinium is 64, terbium is 65, dysporium, holmium, erbium, thulium, ytterbium and lutetium. So these are the 14 elements of the lanthanide series. In gadolinium and lutetium, the 4f orbitals are exactly half-filled. That is why they are highlighted in the electronic configuration. When you write the electronic configuration, they are exactly half-filled. Okay, so they will be more stable, and one electron enters the 5d orbital. So what is happening, they are half filled and completely filled, and one electron enters the 5d orbital. Hence the general electronic configuration of 4f series எப்படி எழுதலாம்னா xenon 4f1 to 14 5d021 and 6s2. And oxidation state of lanthanoids, the common oxidation state of lanthanoid is +3. In addition to that, some of the lanthanoids show either +2 or +4 oxidation state. So gadolinium 3 plus and lutetium 3 plus ions have extra stability because they are having half filled and exactly filled or completely filled 4f orbitals. So their electronic configurations வந்து GD3 plus க்கு xenon 4f7, lutetium க்கு xenon 4f14. So similarly cerium and terbium attain 4f0 and 4f7 configurations respectively in +4 oxidation states. So இதெல்லாமே +4 oxidation state ல இருக்கும்போது cerium and terbium also they are attaining the completely filled and half filled state. Europium 2 plus and ytterbium 2 plus ion have exactly half filled and completely filled 4f orbitals respectively. So the stability of different oxidation states has an impact on the properties of these elements. So they have shown the different oxidation state. The common oxidation state, if you can see here, +3 is more common, and +2 and +4 are exhibited by neodymium, and +4 and +3 are exhibited by cerium, praseodymium. So few elements exhibit two oxidation state. Only neodymium exhibit all the three possible oxidation state, but the common oxidation state of lanthanide series is +3. Now what happens to the atomic and ionic radii? So as we move across the 4f series, so here we cannot examine the periodic trend from top to bottom. We cannot examine because we are having only two rows. So we have to examine only along the period. As we move across the 4f series, the atomic and the ionic radii of lanthanoids, they are showing the gradual decrease in atomic number. So this is because of the lanthanide contraction. So our ionic size வந்து decrease ஆகுது, and they are also calling it as lanthanide contraction. So what is this lanthanide contraction and what is the reason behind this lanthanide contraction? Very, very, very important 5-mark question, repeated question. So listen carefully. As we move from one element to another in 4f series, அதாவது சீரியம்லேருந்து லுட்டீஷியம் வரைக்கும் 4f series தான் நம்ம மூவ் ஆகிட்டே இருக்கும் போது நியூக்ளியர் சார்ஜ் இன்க்ரீசஸ் பை 1 யூனிட். அதாவது சீரியம் டு லுட்டீஷியம், சீரியம்க்கு அடுத்த எலமெண்ட்டுக்கும் அதுக்கு அடுத்த எலமெண்ட்டுக்கும் ரெண்டு எலமெண்ட்டுக்கும் எவ்வளோ தான் இன்க்ரீஸ் இருக்குது, ஒரே 1 யூனிட் தான், நம்பர் 1 தான் டிஃப்ரென்ஸ் இருக்குது. ஸோ நியூக்ளியர் சார்ஜ் வந்து ஒரே ஒரு பாயிண்ட் இன்க்ரீஸ் ஆகுது, அண்ட் தி அடிஷ்னல் எலக்ட்ரான் எங்கே ஆட் ஆகுதுன்னா சேம் இன்னர் 4f subshellயே தான் ஆட் ஆகிட்டுருக்கு. We know that 4f subshell have a diffused shape and therefore the shielding effect of 4f electrons is relatively poor. So இந்த 4f subshell உடைய ஷேப் பார்த்தீங்கன்னா diffused shapeனா ப்ராப்பர் ஷேப்பாக இல்லாமல் கொஞ்சம் diffusedஆக இருக்கிறதுனால they are not showing good shielding effect of 4f electrons. So they are poorly shielding the 4f electrons. Hence, with increase of nuclear charge, the valence electrons are pulled slightly towards the nucleus. அப்போ இந்த ஷேப் diffused ஷேப் இருக்கிறதுனால இந்த எலக்ட்ரான்ஸ் வந்து ப்ராப்பராக நியூக்ளியஸை ஷீல்டு பண்ணாததுனால they are having a contact, they are trying to have contact with the nucleus. அப்போ நியூக்ளியஸோட கான்டாக்ட் ஆகும்போது என்ன ஆகும், அட்ராக்ட் பண்ணும். அது என்ன பண்ணும், அவுட்டர் ஷெல்லில் இருக்க எலக்ட்ரான்ஸ் எல்லாமே நியூக்ளியஸ்க்கு அட்ராக்ட் ஆகும் பிகாஸ் ஆஃப் த poor shielding effect. As a result, the effective nuclear charge is experienced by the 4f electrons and increases the size of lanthanum 3 plus ions will be decreasing. So இது அட்ராக்ட் பண்ண என்ன ஆகும்னா சைஸ் டிக்ரீஸ் ஆகும். ஸோ நம்மளுக்கு lanthanide contraction எக்ஸ்பீரியன்ஸ் ஆகுது. அப்போ 4f electrons எல்லாமே what is happening, they are attracted by the nucleus, so size of the ions are decreasing. So lanthanide contraction of various lanthanoid we can see here, so it is decreasing. So why it is decreasing, we can see from lanthanide to lutetium. So what are the consequences, இப்படி size decrease எப்படி இப்போ எதனால நம்மளுக்கு வந்து இந்த contraction வருதுன்னு புரிஞ்சிருச்சா, because of the diffused shape of the orbital and they are showing a poor shielding effect for the electrons for the valence from the valence shell. So the valence electrons are contact with the nucleus, so they are getting attracted by the nucleus and the size is shrinking. So that is lanthanide contraction. So what are the consequences? So in the lanthanide contraction நடக்கிறதுனால என்ன consequences இருக்கு. So basicity difference will be there. As we move from cerium 3 plus to lutetium 3 plus, the basic character of lanthanum 3 plus ion is decreasing. So cerium to lutetium பார்க்கும்போது if you can see here, basic character of lanthanide ion is decreasing. So due to the decrease of Ln3 plus size decrease ஆகிறதுனாலையும் basic character decrease ஆகுது. So lanthanum hydroxide உடைய basic character decrease ஆகுது because of the small size of the lanthanide. Lanthanide ion க்கு ஏன் கம்மி ஆகுது, because of the lanthanide contraction. So covalent character, so bond lanthanide and hydroxyl ion உடைய basic character decrease ஆகுது, covalent character increase ஆகுது, which result in the decrease in basicity. And what are the similarities among the lanthanoids? If the complete 4f series only 10 picometer, இந்த 4f series full limit 10 picometer தான் decrease ஆகுதுனா atomic radii and 20 picometer decrease in ionic radii is absorbed. So what they are saying, 4f series complete ஆவே 10 picometer தான் atomic radii and 20 picometer of ionic radii complete கம்மி ஆகுது because of the very small change in radii of lanthanoids. Their chemical properties are quite similar. So picometer is 10 power minus 12. So இது வந்து 10 picometer 20 picometer ன்றதுனால that is not a big number. So இவங்களுக்கு ரொம்ப பெரிய சேஞ்சஸ்லாம் இல்லாமல் இந்த கான்ட்ராக்ஷன் வேல்யூஸும் ரொம்ப கம்மியாக இருக்கிறதுனால chemical propertiesல பெரிய சேஞ்சஸ் வரல. The elements of the second and third series resemble each other for more closely than the element of the first and second transition series. Elements of second and third transition series என்ன பண்ணதுன்னா, they are showing the resemblance character more closely to the first and second. So second and third resemble each other and more closely to the first and second. So 3D series and 4D series 5D series எடுத்துக்கிட்டிங்கன்னா டைட்டேனியம்க்கு 135, zirconiumக்கு 145 picometer, hafniumக்கு 144, which is not a that is more close values இருக்கு. So this is all about the lanthanides. Tomorrow we will discuss about the actinoids. With that we will complete this chapter. So actinoids will continue in the next class. Thank you.